IBM Bluemix offers 3 deployment models, allowing developers to build applications in whatever way they prefer. First, Cloud Foundry technology enables an instant, app-centric runtime environment. Second, Docker container technology is a portable and consistent delivery platform that enables development and deployment of applications without having to manage IT infrastructure or an operating system. Lastly, OpenStack virtual machines allow the most flexible and control over the environment. These offerings allow one to use a single set of credentials with common service binding and standard consumption models, giving the ability to effectively and efficiently develop and deploy apps in whatever mode makes the best sense. Bluemix offers different fit-for-purpose models for running applications. This chart shows a summary of Cloud Foundry, Docker containers, and OpenStack virtual machines based on different operations and usage patterns for applications. Cloud Foundry is an open-source platform as a service. It provides a choice of clouds, developer frameworks, and application services. Cloud Foundry makes it faster and easier to build, test, deploy, and scale applications. It is an open-source project and is available through a variety of private cloud distributions and public cloud instances. Cloud Foundry takes an open approach to platform as a service. Most platform as a service offerings restrict developer choices of frameworks, application services, and deployment clouds. The open and extensible nature of Cloud Foundry means developers will not be locked into a single framework, single set of application services, or a single cloud. IBM Bluemix extends Cloud Foundry with a number of managed runtimes and services, enterprise-grade DevOps tooling, and a seamless overall developer experience. IBM Bluemix is the IBM Open Cloud platform that provides mobile and web developers access to IBM software for integration, security, transaction, and other key functions, as well as access to software from IBM business partners. Built on the Cloud Foundry open source technology, Bluemix offers more control to application developers. The goal is to simplify the delivery of an application by providing services that are ready for immediate use and hosting capabilities to enable development operations. With the broad set of services, runtimes, and APIs in Bluemix, the developer gains control and flexibility and has access to various data options, from predictive analytics to SQL and NoSQL databases. Containers are virtual software objects that include all the elements that an application needs to run. A single container includes just the application and its dependencies, running as an isolated process on the host operating system. Therefore, it has the benefits of resource isolation and easy allocation, and is portable and efficient. Containers provide the ability to build high-quality apps fast. Docker is an open platform for developers and system administrators to build, ship, and run distributed applications. Consisting of the Docker Engine, a portable, lightweight runtime and packaging tool, and Docker Hub, a cloud service for sharing applications and automating workflows, Docker enables apps to be quickly assembled from components and eliminates the friction between development, QA, and production environments. As a result, IT can ship faster and run the same app unchanged on laptops, data center virtual machines, or any cloud. This slide illustrates the components of Docker containers and shows the container lifecycle through the build, store, and run stages. A Docker file is a text document that contains all the commands or instructions to build a Docker image for your application. Containers are virtual software objects that include all the elements that an application needs to run on the host. Images are read-only templates from which Docker containers are launched. A Docker image is a layer in the file system. The container build engine reads a Docker file and pulls information from a source code repository. The Docker file provides the instructions needed to build a container. Then the image is pushed to an image repository for storage and sharing. The Docker engine on the server side will pull the image from the repository and run the image on the host operating system. Containers are built up in layers. Layer 1 is an initial layer based on a pre-existing image, and Layer 2 is the actual container content. This approach eases updates, enhances portability, and provides faster startup time. Containers enable you to build your app in any language with any programming tool. A container is created from an image, which is a read-only template. Containers can be ran, started, stopped, moved, and deleted. Each container is an isolated and secure application platform. Apps and containers can run anywhere from development workstations that are running OS X or Windows, servers that are running Ubuntu, or production data center hosts that are running enterprise Linux operating systems. The command language used inside a Docker file is fairly basic. This example creates a new Docker image based on the provided Liberty Profile image, then starts a Liberty Profile server running a sample web application. This chart shows some simple commands that build a new image, then pushes the image to and pulls the image back from a Docker host server. Finally, the Docker image is started.
IBM Bluemix provides the IBM Containers infrastructure as a feature that is available in select regions. Containers enable you to build your app in any language with any programming tools. A container is created from an image, which is a read-only template. Containers can be ran, started, stopped, moved, and deleted. Each container is an isolated and secure application platform. Apps in containers can run anywhere. Development workstations that are running OS X or Windows, servers that are running Ubuntu, or production data center virtual machines that are running Red Hat or other flavors of Linux. The IBM Containers engine's lightweight runtime enables rapid scale up and scale down in response to changes in demand. On Bluemix, development with containers starts with a trusted container image. From a private repository, one can automate their build pipeline and share artifacts with collaborators through public or private registries. Containers simplify system administration by providing standardized environments for development and production teams. Containers help remove the complexity of managing different operating systems and underlying infrastructure. Five key differentiators that Bluemix containers provide are: 1. Developers have the ability to download and run containers on-premise prior to running in the public cloud. Using the IBM Container Extensions command line tool, deployment automation of containers to private and public clouds is easily achieved. 2. With security and privacy as top concerns, publicly accessible registry hubs are not an ideal place to store images. The IBM Container offering on Bluemix provides a private image registry with access controls to ensure only approved parties can access them. 3. Insights like CPU usage, memory, and network utilization per container and access to logging messages are available as soon as new containers are deployed. 4. Public IP addresses are easily assigned to deployed containers using the ICE tool. And 5. IBM Containers' lightweight runtime engine enables rapid scale up and scale down in response to changes in demand. A virtual machine is a software implementation of a computer that executes programs like a real machine. Within the virtual machine is a complete operating system and application software stack. A hardware virtualization layer is provided by a hypervisor and separates the virtual machine from the host. The hypervisor allocates resources as needed and allows many virtual machines to run simultaneously on a single host system.
IBM Bluemix provides virtual machine infrastructure offerings as a beta feature that is available in select regions. This infrastructure enables you to create virtual machines that are running in private and public OpenStack clouds. Private on-premise clouds must first be connected to Bluemix before making it a target for your virtual machine images. With virtual machines in Bluemix, you can create group instances for public and private clouds by using existing virtual machine images. You can provision virtual machine groups with auto-scaling and load balancing against a target. You can view detailed information of each virtual machine instance. Details include instance ID, IP address, number of CPUs, total memory, disk size, and the virtual machine status. You can stop, pause, or delete instances. You can also perform advanced options from the provided OpenStack Horizon dashboard or from OpenStack APIs. This chart shows some of the differences in use cases between containers and virtual machines, specifically regarding build, deploy, and update lifecycle of an application. Deployment of applications to the cloud should be done in a repeatable way through standardization. It is important to make choices in cloud technology that deliver the best value and make the best business sense. We will explore the Cloud Foundry approach in detail in Section 2. Here is a list of useful bookmarks on the topics we covered in this section for your reference. If you have any questions or comments regarding this content, please post them to the Bluemix community on DeveloperWorks or by following this IBM Biz short URL. Thank you for your time.